think about it. Okay. Well, what happens when these glaciers move through the valleys? Where do they go? Well, eventually they're going to end up somewhere out around sea level. Wherever the valley went, there's a drainage valley before that's where these are going to end up. In this case, you can see this glacier. This is College Fjord in Alaska. See this glacier coming out, and it's just eventually spilling out into the bay. So here I've got this huge glacial ice debris, and it's ramping out into the bay, and it doesn't get very far. It's not an ice shelf. It didn't freeze as water from the bay. It's glacial ice coming down the mountain and spreading out into the bay. And you can kind of get a sense of it. Look at the glacier back here. You see all the pieces breaking off, floating away as icebergs. Here's a cruise ship, big cruise ship, to give you a little sense of scale on how that looks. And if you go all along the inside passage, up along British Columbia, up into the south shore of Alaska, this is the kind of topography you see. And this picture is actually from Alaska here. And you see these big, long fjords being cut. These valleys just being streamlined by these glacial tongues of ice coming through them, U-shaped, deep, deep, narrow, straight sides. And when the ice melts and the seawater floods back into these valleys, we call them fjords. So a fjord, Swedish term, you can see one here, and you can just see kind of the U shape that it appears to have. You see how it's narrow, straight, deep, and you just see how the glacial trough was carved out. Okay. Let's shift gears and look at the other kind of landscape that we would expect to see, a depositional kind of landscape. All of this material that we've been picking up with the glacier in the erosional part, it's got to go somewhere, right? And the glacier is, of course, carrying it along downstream. In our case with the last glacier, that means going from north to south. So our glacier was erosional back up here over Canada, but by the time it got down here to the lower peninsula of Michigan, in the western part of Michigan's upper peninsula, it had shifted over to being deposition. It just couldn't carry all that debris. There was so much. The ice could only handle so much of it, and it just stopped picking up debris. And then it stopped dumping it out. It started dumping it out. It just couldn't handle it. A lot of this was due to the fact that the ice had reached its maximum extent, and now it started to melt. And the climates had changed, the ice was melting, and as it melted, it was effectively retreating, wasn't it? It hadn't changed its direction of motion, but the front edge of the ice was moving backwards as the ice simply melted away, leaving the debris in its place. So some of that we see in this transition is just happening right along the edge of the ice, where we see ice pieces breaking off, floating away in the bay. As the icebergs melt, all the debris that's in the ice is just dropping out of the system. It's plopping into the sediments at the bottom of the bay. And what we end up seeing now, soft sediment, stone coming down, plop into the mud. It's going to make kind of a crater. And we can see that structure in the resulting sediments. These are what we call drop stones. So whenever we see a drop stone, we go, this used to be an old bay. There was a glacier up there. And this stone got dropped in from that glacier. So that tells us something about the environment of deposition real fast. Or sometimes you're out in the field and you see this big rock, this big giant boulder, and it just is totally out of place. And you kind of go, where the heck did that come from? Glaciers. It's a glacial erratic. Here you can see we've got this beautiful granite gneiss, it's sitting on another granite gneiss, but they're entirely different. This came, and look at how it's got these flat sides to it, what we call facets. That's basically where that big block was held in the ice, and it was just ground along the bottom. So it was basically ground off by the ice. It then kind of tumbled over. That edge got ground off. So all these flats were being ground as this thing was dragged over the bedrock by the ice. Here you've got this boulder out in the middle of the fields out in North Dakota, just way out of place. Well, I had an early experience with a glacial erratic when I was my first geology course. And I'll tell you that now. I was lucky enough to have a geology course from a guy by the name of Bob Dodd, who was like a geo god of Wisconsin. He was one of the big names in geology. And he took us out on a field trip. And we went out in the middle of this farmer's field, and there was this big, giant carbonate conglomerate. And it was kind of like, holy cow, where did this come from? He said, look, just sit down. I want you to write a page as to how this could possibly be here. And of course, we all scribbled away like crazy, turned in our papers, and to the man, we all said, glacial erratic. It's way out of place. Couldn't possibly be here, yada, yada, yada. And then he said, okay, you want to know how this really got here? He said, this is actually a concrete dam. It was put in by the WPA in the 1930s with the farmers' help, and the pond is all silted in behind it, as ponds do. And he said, over the years with the frost heave, all of the face of the form work on the cement has broken off, and all you see is this pebbly interior of the concrete. And he says, it's not an erratic, it's put here on purpose by man. He says, don't always believe what you think.